Thanks, Hart. Our customers, especially in the automotive market, tell us that one of the key challenges they face is overcoming slow boot times on Linux and Android systems. The next generation of the products they are working on has a growing collection of applications, as well as more sensors and other peripherals that need to be initialized. Yet their customers still expect an instant-on experience. Today, developers spend weeks, if not months, struggling to optimize boot performance, only to have to start the process over again as their systems evolve. Today, Datalight is talking about a new product called NitroBoot. NitroBoot provides the fastest way to not just boot an embedded Linux system, but to get to the point where user input can be accepted. Our testing showed significant improvements in time to application ready, which is really the time that matters. Developers today use a variety of approaches to reduce time to application ready. These approaches are used independently and together can be quite effective. However, each has drawbacks that impact the cost and hassle factors and make them less than ideal or complete. There is a lot of discussion in the community about techniques for hand pruning the driver stack. This requires a pretty high level of expertise and is time-consuming. Also, the startup time for the application itself is really not addressed. If you update to a new kernel or change devices, you've got to start all over again. Using sleep mode is another technique. What we've heard from customers is that this is problematic because it requires sustained battery power, which is a critical commodity in most embedded systems. Alternatively, Hibernate represents a low-power option, but the time to restore the system escalates as memory size grows, so the next generation system that has greater RAM requirement will be slower, not what customers want. NitroBoot overcomes many, if not most of these challenges by combining proprietary techniques with hibernation technology. Boot times are consistently fast, regardless of RAM size, and it doesn't require the level of development time that hand pruning drivers does. So how does it work? The process of restoring a hibernation image is kind of like stuffing a pig through a snake. You have to take the entire image that was saved to your non-volatile storage, and you have to get it back into RAM as quickly as possible using whatever interface you have available. In contrast, NitroBoot breaks the image into bite-sized chunks. The NitroBoot core learns about the system and prioritizes what gets restored when. It takes a snapshot of the RAM of the running system and then moves the critical pieces back into RAM in priority order. Sounds simple, right? The best technology does. So let's talk about how NitroBoot gets integrated into the system. NitroBoot consists of several pieces, including low-level BSP components that manage initialization, together with a snapshot driver and shell script that integrate higher up in the stack. Applications don't need to have any modifications to work with NitroBoot. Yes, NitroBoot can be used in a secure boot environment. Secure boot processes can be used to verify NitroBoot itself, while verification of the snapshot image can be handled within NitroBoot. This will provide robust security alongside dramatically shortened boot times. NitroBoot can be configured in a couple of ways to support different use cases. If your system settings don't need to be persistent, or if all the applications are installed during manufacturing, you can use static mode, which captures a snapshot image only once, and when booting, brings the system up in a factory fresh configuration. If, however, persistent settings are required, or apps get installed in the field by the user, and there is time during the normal shutdown for a snapshot image to be captured, dynamic mode provides the ability to restore the system to the last state the user experienced. A third option is one that uses the image captured during manufacturing, along with some dynamic information, to bring the system up to an application-controlled point. This static plus mode is the one that conforms to the expectations of Android systems. Unlike standard Hibernate, NitroBoot's snapshot image will ignore unused portions of the RAM contents, like certain caches. In addition, some systems could benefit from adding compression to the snapshot process. if the RAM image contains compressible components like text or uncompressed images. NitroBoot was developed by a partner of ours in Japan and has been on the market for several years. There are over 10 million units in the field using this technology. I'd like to share a few examples of the products. In-car infotainment systems are a natural fit for NitroBoot, given the tough boot time standards they need to meet. Fujitsu 10 and other Tier 1s in Japan are currently using the product to improve boot speed on their Android systems. A similar application is this GPS chart plotter that is used in marine shipping and commercial fishing vessels. But my favorite might be this karaoke DJ machine from Pioneer. They moved to Linux from a proprietary system and found that the slow boot times made the product virtually unusable. By integrating NitroBoot, they were able to achieve the same fast boot experience that their customers had come to expect from their products. Let's take a minute to watch a demonstration showing a side-by-side comparison. Boot times will vary depending upon many factors in the system. The thing to note here is the relative speed. We're using two identical i.MX6Q Sabre SDB boards. On the left, the system uses the stock Yocto Linux, and on the right, we've just added NitroBoot. And we hit the power button. Both boards boot up to a Wayland graphical desktop, then launch a web browser displaying a page from the Datalite website. The page is stored locally just to ensure network latency is not a factor. NitroBoot has the system ready for user input in about 7 seconds. The stock system is performing a normal boot to the Wayland desktop. Once Yocto has loaded the kernel and the Wayland desktop, the time it takes to start the browser and load the web page is only a few seconds. A different application with a longer initialization time would typically result in an even greater difference in boot time. The stock system is finally up, after a painfully long 42 seconds. It's said that you never get a second chance to make a first impression. So for this configuration and application, the difference between the stock system and the one enhanced with NitroBoot would result in a much better first impression. We did not have to make any modifications to the standard web browser application, and both systems loaded identical copies of the locally stored web page. NitroBoot provides significant boot time improvements for many different types of systems, but there are some constraints on its use. If your application needs to have exclusive access to the storage device during startup, like if your file system has only a single read thread, or if there are drivers in your system that don't support Hibernate and you don't have the source code for them, or if there simply isn't any room at all to store a snapshot image, NitroBoot may not be the right choice. NitroBoot has been ported to many different ARM32 and 64-bit processors and will be available in the fall for x86. If your system isn't currently on our supported list, chances are that NitroBoot can be customized to work with it. If you have a configuration that isn't exactly what is on our supported list, you may be able to tweak one of our existing kits to work in your system, or you can have our engineers port it for you. Some modifications are easier than others. This diagram provides a high-level perspective on the level of effort required. The product comes with a comprehensive set of manuals and guides. Things like changing what storage media holds the snapshot image are very straightforward, and typically customers would do that type of mod themselves. Supporting a different SoC that is based on a supported processor series is only slightly more complicated. You could do that yourself, or if resources are at a premium, Datalite can do that work as NRE. If you need support for an entirely different processor series, you would need to schedule NRE time with Datalite for that work. Using different drivers would range from simple if the driver supports Hibernate, to very complex if hibernation support needs to be added. NitroBoot kits are delivered electronically in a combination of source code, object modules, and kernel patches. Each configuration has a developer's guide that is customized for the specific environment. If NitroBoot sounds like a solution for your system, we encourage you to evaluate it on a supported platform, such as the i.MX6 Sabre or the Raspberry Pi. Next, consider what level of customization would be required to meet your project needs. We're happy to consult with you on this aspect. So now I want to pass control back to Hart to open up the call so we can answer any questions you may have.